In this video, we will talk about how to add and subtract monomials. So here's the rule that we need to keep in mind. To add or subtract monomials, they must have the same variable and the same exponent. So with that in mind, let's check out a few examples of how to add and subtract monomials. Let's say we have 10x squared plus 3x squared. So to check if we can add these two together, we're just going to ignore these numbers out front. These aren't really important at all. We first need to focus on their variables. So here we have an x. And here we have an x, so that's good. They have the same variable. And next we need to check the exponents. So this has an exponent of 2, and this x also has an exponent of 2. So because they are the same variable with the same exponents, that means we're allowed to add them together. So all we have to do is just 10 plus 3, which is 13. So our final answer will be 13x squared. All right, let's try another example. Let's say we have 10x plus 3x squared. Can we add these two together? Well, first we'll check if they have the same variables. So this first monomial has an x, and this second monomial also has an x. So that's good. Now we need to check if they have the same exponent. So this one, no exponent is shown, so we can assume that it's a 1. Well, we can see that this x has an exponent of 2. So since these two are not equal, we cannot add them together. So this is just going to be our final answer. There's no way to simplify this expression. Let's try another one. Let's say we have 3xy plus 5xy. Can we add these two monomials together? Well, remember, we're just going to ignore these numbers out front for right now, and let's focus on the variables. So this monomial has an x and a y. This monomial also has an x and a y. And we can see that both the x's and the y's are all raised to the power of 1. So they have the same variables and the same exponents, so we are allowed to add them together. So all we have to do is say 3 plus 5, which is 8. So our final answer is 8, along with the variables that they share, so an x and a y. So that is our final answer. All right, let's try this one. 6xy squared plus 7y squared x. Can we add these two together? Well, first let's focus on the variables. So we can see this monomial has an x, and this one also has an x. This monomial has a y, and this one also has a y. And we can see that the y's are both raised to the power of 2, while the x's are both raised to the power of 1. So we are allowed to add these two together. So even though the x's and the y's are written in different orders, that's not important. If we wanted to, we could rewrite this one as 7xy squared to put the x's and the y's in the same order, but it's not necessary. So just keep that in mind. The variables don't have to be in the same order. They just have to be the same variables with the same exponents. So with that in mind, all we have to do is add 6 plus 7, which is 13. So our final answer is 13xy squared. And again, it doesn't matter which order we write this in. If we wanted to, we could also say 13y squared x. It's the same either way. So that's our final answer. All right, let's try this one. We have 13x squared minus 5x squared plus 2x to the third. So we'll notice that all three terms have an x, but only these first two terms have an x raised to the same power. They're both to the power of 2. So we're allowed to subtract these two, but we can't add this one into the mix. So the final answer that we're going to get is just combining these two. So 13 minus 5, that's 8. And it will be an x squared. And then we can just include this last term as it is. So it'll be plus 2x to the third. So because these x's, again, because they have different exponents, we can't add those two together. So we just have to leave it like this as our final answer. All right, let's try one last example. We have negative 20x to the fourth plus 4x minus 4x to the fourth minus 6x. So every term has an x, but notice that these are the only two terms that have an x to the fourth power, while the other two terms, we can imagine they both have an x to the 1. So we can start by combining these two terms, since they have the same variable and the same exponent. So negative 20 minus 4, that's negative 24. So we can write negative 24 x to the fourth, and then we can combine these two terms, since they also have the same variable and the same exponent. So we have 4 minus 6, that's negative 2, so or minus 2. And then remember we have x to the first, and we don't have to include that 1 if we don't want to. So this is our final answer.